Hi guys, welcome to iQuanta. Already I guess you have gone through ratio 1. This is the second part of ratio. And we are basically creating this playlist for entire arithmetic, and I hope after doing this you don't need anything in arithmetic because this is very exclusive content which we are producing here. Now the next thing what we do, we have already learned the basic of ratio and the comparison. In today's session what we will do mostly in certain properties and concepts of ratio. And similarly, we also learn some questions based on it and hope you will love it. So first is like the basic of ratio, which let's say I make you understand like how we use ratio. So think about it, certain kind of question like this, let's say A is to B is basically let's say 2 is to 3. And you have also let's say B is to C is 3 is to 5. So in this case, if I ask you to find what is A is to C or what is A is to B is to C, it's very simple because B is basically equal in both cases. Now if I need to find what is A is to B is to C, in case of A is to B is to C is nothing but 2 is to 3 is to 5. That is A is to B is to C. And what is A is to C? That is 2 is to 5. Why it is very simple? Because we have one thing common here, that is the 3 portion. And this 3 portion, if it is common, so we can use it here directly. Now think about it when this portion is not same, when this portion is basically different. So I give you example, let's say, if A is to B is 2 is to 3, let's say, and if B is to C is 5 is to 7. So in this case, how we find A is to B is to C? So in this case, you need to understand like if A is to B is 2 is to 3 and B is to C is 5 is to 7, so you have to make sure the B quantity has to be equal. Now in case of B quantity, here like the B is in the first part is 3, in the second part is 5. So what I will do, what is the shortcut for doing this is I'll just multiply 5 with this ratio. I multiply 5 with this ratio because 5 is here, and I multiply 3 with this ratio. So you understand? To use this B to multiply this one and use this B to multiply this particular section. So what you'll get in this case I can find, and I know if I multiply same thing with numerator as well as denominator, the value won't change. So in this case, I can say it is 10 is to 15. And similarly, if I multiply 3 here and 3 here also, it becomes 15 is to 21. So what I basically did, I made the B portion equal. So that is the first thing you need to understand, like how you make the B portion equal. So this is one method. Second method is you can go towards the LCM also. But this is like the fastest way to solve this kind of question. So in case of this, what is A is to B is to C? A is to B is to C has to be 10 is to 15 is to 21. I hope I make you guys clear like what basically we are going to do. In this type of question, if they have asked directly what is A is to C, now A is to B is given, B is to C is given, and they have asked you what is categorically directly only A is to C. In that case, you can do it directly also because A by B into B upon C. So that is basically what is A upon B, that is 2 upon 3. What is B upon C? That is 5 upon 7. So if you multiply, B we cancel out, so it will become A upon C is basically 10 upon 21. So that is one way of solving this type of question. And remember, like this is very important because in this way you can do for the multiple cases also. Let's say in case of A is to B is given, B is to C is given, C is to D is given. Now how you can find A is to B is to C is to D? So this kind of thing. So these are like very, very crucial while solving this type of question. And you can see the visual also like how we use basically the basic kind of ratio to find like this complicated ones also. So these are the basic, like what we are basically using the basic while finding the values of ratio. In the next part, we will discuss basically some applications of and properties of ratio. So the properties of ratio is very important. So I will write down the most of the properties and that properties which can be seen in your screen obviously. So the first property which we're going to learn is like, it is known as the basic property of ratio. First is like if you do multiplication or division, there is no change in values, right? So it has already, I have already told you, like if A upon B is there, if A upon B is there, I can write it is AK upon BK. And similarly, it is same as A upon K upon B upon K. And please remember, K should not be equal to 0. Because if K is 0, then it becomes 0 upon 0, which is undefined. That is the first thing. Now, the second thing what we learn here, which is also very important, that is in case of property. So if the ratio is like this, like if A by B is equal to C by D, so that I can say this ratio and these two ratios are equal. So we can say these quantities are basically proportional. So I can say A is to B is same as C is to D. And what does it mean? AB and CD are basically nothing but proportional. Now the third is, from this concept only, we can also use like A upon B is not equal to A plus X upon B plus X. Please remember this, if X is not equal to 0. So these are very important properties what we basically going to learn today. The second few properties which is also important, which is in ratio obviously, which I've already learned about the comparison, and now we can use this kind of ratio, which is A upon B equals to if C upon D. So I can write A plus B upon B is equal to C plus D upon D. Or also we can write A upon A plus B is equal to C upon C plus D. So you understand whatever I'm doing in the left side, I'm doing the same operation in the right side. If we do the same thing, the values are always equal. Or else I can say also A upon A minus B is equal to C upon C minus D. So if you do the similar kind of operation in any side, it has to be equal. And I'll give you one example also. Let's say I can say 1 upon 2 is equal to, let's say, 3 upon 6, right? So I can write 1, so A plus B upon B, so 1 plus 2 upon 2 has to be equal to 3 plus 6 upon 6. Now this is, check this, what is the value of this? The value of this is 3 upon 2. And what is the value of this? That is 9 upon 6. And 9 upon 6 is same as 3 upon 2. So that means the things are basically being unchanged. And please understand here, like all of these like properties are very basic for ratio. And one of the important properties also, which is known as componendo dividendo, that is A plus B upon A minus B is equal to C plus D upon C minus D. Very important property which is known as componendo dividendo. So these are the major property of this chapters. So you have to understand this property and remember also, because this property may be used to solve much more questions. The next case we do, we will know some more properties of ratio, obviously. In this case, like we are using those properties which we basically use in application. So let me give you some example of it also. So the first thing is that, let's say if I have A upon B is equal to C upon D. Understand it very carefully. A upon B equals to C upon D. So in this case, we can write it is also same as A plus C upon B plus D. It is also same as A minus C upon B minus D. It is also same as any kind of linear arrangement on it. That means MA plus minus NC upon MB plus minus ND. Now you can understand, like if I'm multiplying M with A, I am multiplying M with B also. If I'm multiplying C by N, then I'm multiplying D by N also. So these are like same kind of things. If I'm doing, the values won't change. But one thing you should understand, like if I make it like this, let's say A square plus C square upon B square plus D square. If I just do it like the squaring, right? So in this case, it has to be equal to A square upon C square, not A upon C. So if I do the square, if I do any nth format, so in this case, this thing is basically happening. So it has to be equal to the power of this thing. So please understand this thing. It is very crucial to understand. And second, very important concept also, like if it is like three things also, let's say if A is to B is same as C is to D is same as, let's say, E is to F. So I can use these properties, all of these properties in case of three ratios as well. All of these things. Just it has three components. Similarly, you have to understand if this is given, we can also use this particular concept to solve questions as well, which is A upon B equal to C upon D equals to E upon F. We can equate it with K. Now, what do you mean by when I am equating it with K? K is basically a constant. So if all these ratios are equal, so they can be equal to K. And in this case, I can write directly A equals to BK and C equals to DK and E equals to FK. So these are the basic things which we need to use in ratio, and this is like the basic concepts which we are going to use ratio. And remember one thing very clearly, like whatever we are doing in ratio now will be based on this particular things only. So let's discuss some questions based on this kind of concept. Now think about this question. This question is given. You can see this. A upon B plus C, it is given exactly. A upon B plus C equal to B upon C plus A equal to C upon A plus B equals to R. Now I need to find the value of R. So while solving this type of question, the first thing it should come to your mind, like we are going to use property to solve this question. There are so many ways it can be solved, so many other ways, but our objective is to use properties, and let's check how we can use it. So first thing you need to understand which property we are going to use. I'm going to use this property, which is basically A upon B if it is equal to C upon D. So it is same as A plus C upon B plus D. So this property I'm going to use. So this is the property which I will be using here. So think about it like this way. So if I have A upon B plus C, A upon B plus C is equal to B upon C plus A is equal to C upon A plus B. So in this case, what can I write? I can use the entire thing together. So I can add all the numerators, I can add all the denominators. So if I'm adding numerators, it will become A plus B plus C, and if I'm adding denominators, it will become B plus C plus A plus A plus B. So if I finish it here, so it will basically nothing but A plus B plus C divided by twice upon A plus B plus C. Now why it is twice upon A plus B plus C? Because B occurs twice, A occurs twice, C occurs twice, right? So it is twice upon A plus B plus C. And remember, this is also equal to R. So I can use R equals to this, right? So I can say R equals to this. The first thing we can understand from here, like just cancel it out, A plus B plus C. Now if you cancel it out, A plus B plus C, it will become half, exactly half. Now think about like A plus B plus C and A plus B plus C if I am cancelling out. So the first thing you need to understand, this cannot be 0. If this is 0, the entire thing will be 0 upon 0, right? And when it is entire thing is 0 upon 0, it is undefined. So if A plus B plus not equal to 0, then this is half. So I can write if A plus B plus C not equal to 0, then the value of this R is half. So for one case, the value of this is half, right? What about the second case? The second case is if A plus B plus C equals to 0. If A plus B plus C equals to 0, then what can I write? I can write B plus C is nothing but minus A. Am I clear? Because A is basically going in this direction, so B plus C is nothing but minus A. Now think about it. Now put the value here. So A upon B plus C. So what is R? R is basically A upon B plus C. Now what is the value of B plus C? That is minus A. So it is A upon minus A. So which is A and A gets cancelled out. So which is minus 1. So this is like the first thing you need to understand here. If A plus B plus C equals to 0, in that case, we can use it directly. That is A upon minus A, which is minus 1. So if A plus B plus C is 0, the answer is minus 1. If A plus B plus C is not equal to 0, the answer is half. So what are the values it can take? The answer has to be half or minus 1. This is your answer, half or minus 1. Am I clear? I hope I make you understand exactly how these kind of things are going. And this is all like a kind of CAT questions which you can get. And I'm not using anything apart from the properties. And let's think about it, how simple it is. I have written this line, but in the question, you don't need to write this line. You just add this thing, it'll get your answer half. And if you want to cancel it out, you have to make it 0. And if you have to make it 0, your another answer is minus 1. So this is how it should be solved. So I hope you are understanding this. And if you're not understanding, please do the pause button, understand it, and then move forward. And I hope you will learn all of these things together. So the next question, let's think about the next question. The next question is A is to B equal to C is to D equals to E is to F. And you need to find the value of this thing. Now again, I have given you the example of this thing, like we can solve this question in two ways, right? One is by using property, one is by not using property. And let's say if you're going to use property, and if you're not going to use property, how we can solve this question? The first thing is without using property. So what is the first step? The first step is A upon B is equal to C upon D is equal to E upon F. Because you can see by checking this question, this is a property question. It is given and you need to find the value of this. And here certain things are given. So you need to find the answer exactly what the answer will match with you. So I can take this as K, and K is the constant, right? That's the first thing I have already told you in this case. Like if it is given, we can use this thing obviously, right? So I'm using now this. So if I'm using this thing and AB equal to CD equals to EF, in this case, the first thing you have to understand, like I can write A as BK, I can write C as dk and I can write E as fk. So it is bk, dk and fk. Now think about it. Now think about it very carefully. Like if this thing is given, so I can use this portion, only check the denominator. So I can put for a square, only check denominators. For a square I can write, what is the value of a? bk. So I can write bk square, right? Minus 6 dk square plus fk square. I'm just using this denominator, this portion. Just I'm using this portion, only this portion. Right? So if I get this thing, now if I take 5k square common, it will become b square minus d square upon plus f square. Now think about the numerator and denominator. Just put it now like this way. So it is 5b square minus 6d square plus f square upon 5k square upon k square, sorry. So I can take common k square from here. So it is basically 5b square, 6d square and plus f square. So it is basically if I take k square common, so it will become 5b square minus 6d square plus f square. And if this thing is not equal to 0, obviously this thing is not equal to 0, then I can cancel it out. So the answer is 1 upon k square. Right. So this thing I get in a constant term. It's the value of this is I am getting 1 upon k square. Now think about it. How we can match this thing with option, right? So I have to match this thing with option. Now how can we match? So if I think a upon b is this, so what is the value of a upon b is k. If c upon d is k, what is d upon c? 1 upon k. Right? Now think about AC upon BD. So AC upon BD can be written as, that is A upon B. Now think about this. So I'm writing this. AC upon BD can be written as A upon B into C upon D. Now what is the value of A upon B? That is K. What is the value of C upon D? That is K. So K into K is basically K square. Again, not the answer. So this is not the answer. 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 So check D. FD upon C. Now if I think about FD upon C, so I can write F upon E into D upon C, right? If E upon F is K, so what is F upon E? So that is the inverse of it. So it will become 1 upon K. If C upon D is K, what is D upon C? Again 1 upon K. So what is your answer? 1 upon K square. So hence that is your value. So your value for this expression is nothing but 1 upon K square. And the value of this expression is also nothing but 1 upon k square. So hence what is your answer? Your answer is option D. So this is one way we can solve this question. Now I have put this space to solve it in another way. So let's check if I'm going to use the formula or like the properties, how can I use it? So now I'm going to use this property. This property I'm going to use. The square ones, right? So think about it. So this is there, let's say first I can write if a square upon b square equals to c square upon d square equals to e square upon f square. And I know if I do any kind of linear arrangement, it has to be same, right? So this has to be equal to, let's say 5a square minus 6d square plus 5a square, so it has to be, so it is a square upon b square equal to c square upon d square equals to e square upon f square. It has to be equal to, like anything if I do, like it's basically, so a square upon b square equals to c square upon d square equals to e square upon f square. It has to be equal to any linear arrangement of this, which is 5a square minus 6c square plus e square upon 5b square minus 6d square plus f square. Now think about it. In the question, what I need to do? I need to find the reciprocal of it. So I need to find the reciprocal, 1 upon this. So if I need to find the reciprocal, which is 5 upon b square minus 6d square plus f square upon 5a square minus 6c square plus e square, it has to be equal to f square upon e square, yes or no? Now if I have it is f square upon e square, this thing can be written as f upon e. Now I need to match with the option. I do not have any option which has f square upon e square. So if I need to match with the option, what I do? F upon e into f upon e. Now the value of e upon f, the value of e upon f is c upon d. So what is the value of f upon e? That is d upon c. So I can write f upon e into d upon c. So your answer is fd upon ce. So hence you'll get the answer, that is fd upon ce. So this is how you can solve this type of questions. So I hope you have understood how I can use the property to solve this type of questions. So let's think about the next question. A student gets an aggregate of 60% marks in 5 subjects in the ratio of this one. If the passing marks are 50% of the maximum marks and each subject has the same maximum marks, how many subjects did he pass the examination? Right? So student gets an aggregate of 60%. कितना मिला है उसको? 60% मिला है, right? And the 5 subjects has equal maximum marks. So the ratio of the marks what he got, it's basically 10, 9, 8, 7 and 6. So if I have these 5 papers and my score is in the ratio 10, 9, 8, 7, 6. So what is the average I got? 8. And it has said that at 50% of maximum marks, right? That's a passing. And he got 60% marks in average. So if the average of 10, 9, 8, 7, 6 is 8, so I can write 8 is equivalent to how much? 8 is equivalent to, 60%. 8 is equivalent to 60%. Because 8 is basically the score of the average and his average score is also 60%. So if 8 is equivalent to 60%, this 10 and 9 has to be more than 60% obviously. Because if 8 is equivalent to 60%, 10 and 9 has to be more than it, right? So that means in 8 he passed, in 9 he passed, in 10 he passed. So I just need to check about 7 and 6. So think about 7. So in case of 7, so what is it? 7, if 8 is equivalent to 60%, 7 is equivalent to 60 into 7 upon 8, which is 420 upon 8 and which is more than 50%. So that means in 7 also he passed. So if 7 is this, so what is 6 equivalent to? That is 60 into 6 upon 8, which is less than 50%. Now if this is less than 50%, I can see very clearly like in 6, he basically not passed this exam. So he failed this exam where his score is in the ratio of 6. That means he passed in this 4 thing. So your answer is 4. So this is the easiest way to solve this question. You can solve this question in other ways as well. And what are the other ways you can solve this question? Let me show you one example. So if you think he got 60% marks, so the first thing you need to take like 10, 9, 8, 7, 6 is there. And you can take like his total score is basically 100 in each paper. So his total score is 100 into 5, which is 500, right? Let's say that each paper has equal maximum marks. So I am assuming each paper has maximum mark 100. Now his total score is 500 into 60%. His total score is 500 into 60%, which is basically 500 into 60 upon 100, which is basically 300. So he totally scored 300 in 5 subjects, right? Now what is this basically score ratio? This one is the score ratio, right? If this one is the score ratio, I can also use the basic concept of ratio or like the equation also. So I can say it is 10x plus 9x plus 8x plus 7x plus 5x is equal to 300. So in this case, you can say like it is 40x is equal to 300. So that means what is x? X is 330 upon 4, which is 7.5. Now you can find all the values of 10x, the values of 9x, 8x, 7x and 6x. And you can find in which subject he actually scored more than % or not. So let's think about 7x. So in case of 7x, what is it? 7 into 7.5. So 7 into 7.5 is more than 50. So hence in 7x, basically he passed. So if he passed in this, so he passed all these 4. Now check about 6. So what is 6x? That is 6 into 7.5. So what is 6 into 7.5? That is 45. So in case of 45, it is less than 50. So in this subject, he didn't pass. So in this way also, you can solve this type of question. So please understand like how we are basically solving the ratio question. These are all basic ratio questions. And we will discuss some more questions on the basic of ratio also in our next session also. And today we are just discussing the basic questions using like the properties of ratio. Next is this question, like it is also like a kind of a ratio question or like the kind of the relation question. This kind of question how you can solve. So it's a very important significance is there. That's why I'm basically trying to solve this question with you guys. So in this type of question, what you need to do, you need to understand, you can take any value. If PQR equals to 1 given, if PQR equals to 1 given, so you can solve it directly also. And you can solve it by different method which is using the values. So I am solving this question by using values this day. Okay? So today I am solving it using values. So what value I can take? I can take the value of P is 1. The value of Q is, let's say, half. And the value of R is basically 2. So 1 into half into 2 is basically 1, right? So I can take this 3 value. Now put the value here. So that is 1. What is the value of P? The value of P is basically 1 and Q to the power minus 1 is half to the power minus 1. What is 1 upon 2 to the power minus 1, right? So plus the next value is 1 plus Q, that is half, and R is 2, so that is 2 to the power minus 1. And the next value is 1 plus 2 plus 1 to the power minus 1. So these are the values we are getting right now, right? So now if I'm getting these values, so the next step is basically just solve it. That is 1 plus 1. And what is half to the power minus 1? Half is like 1 by 2 to the power minus 1, which is same as 1 by, what is 2 to the power minus 1? Half. So 1 upon half, that is 2. So I'm using 2 here. Now plus again 1 plus half. And 2 to the power minus 1 is basically 1 upon 2. 2 to the power minus 1 is 1 upon 2. So it is basically half again. Right? Similarly plus 1 plus 2 plus 1. So hence what is my answer? That is 1 plus 1 upon 4. That is 1 upon 4 plus 1 upon 2 plus 1 upon 4. So if I do 1 upon 4, 1 upon 2, 1 upon 4, what is your value? That is 1. So hence your answer is 1. So you have 1 in here. You have 1 in where? This case. Now think about it. If you just try to find the values of this. So the value of this is P plus Q plus R is 2 plus 1 plus half. It is not equal to 1. So hence this is not the answer. 1 upon P plus Q plus R, which is same as 1 upon 2 plus 1 plus half. Again not equal to 1. So not your answer. P to the power minus 1, Q to the power minus 1, R to the power minus 1, that is 2 to the power, let's say what is the value of P? P's value is basically 1. So it is 1 to the power minus 1 plus 2 to the power minus 1 plus half to the power minus 1. Again, it is not equal to 1. So hence this is also not your answer. So your answer has to be C. So this kind of question we can solve it very easily by just understanding what exactly we are going to do and how exactly we are going to do. So this is the method. It's very important to understand like how we are basically solving in case of this kind of question just by taking values also. Now if someone wants to solve this type of question by using property or by using the general like algebraic identity also, they also can solve this question. And how they can solve this question? This is the method how they can solve this question by using this property as well. So think about it, like if I use this thing in this way mostly, so I can have PQR is 1, right? So what is the value of PQR? PQR equals to 1, right? So in this case, I can find, so I need to convert everything in one particular form, right? So basically, I can write PR equals to 1 upon Q, which is basically same as Q to the power minus 1. So I can convert everything in the form of, let's say, P and R. Fine. So in case of, so if I have PR equals to Q to the power minus 1, so my first term will become 1 upon, which is it 1 plus P plus PR. That is my first term, right? Similarly, the second term, that is the first term, this term will become this. The second term is 1 plus Q plus R to the power minus 1. And I have told you what I need to change. I need to change just the values of what? The values of Q. Because I am making everything in the form of P and PR. So in this case, I have 1. And what is the value of Q? That is 1 upon PR. And what is the value of this? R to the minus 1 upon R. Now do the LCM. So it will become PR and the 1 plus PR plus R, and this is PR. So if I just, this is 1 upon this, so if I just reciprocal it, it will become PR plus 1 plus PR plus R. So this is one way you can solve. Similarly, this is the second one. What is the third one? The third one is 1 plus R plus P to the power minus 1. So this thing also become 1 upon 1 plus R plus 1 upon P. So if you do this, the reciprocal thing, that will become P by PR plus 1 plus R. So if you add these things, if you add all these things, you can see the denominator is equal in all these cases. Now if you're adding all of these things, so it will become like, if I take the thing is also 1 plus P plus PR, and in the numerator also becomes 1 plus P plus PR. Now if this thing can get cancelled out if it is not equal to 0, so your answer will be 1 also. This is the alternate method which you can use here. And in this kind of alternate methods, the most important thing you need to understand, so we can solve any question in this way. So these questions are basically based on the properties mostly. So in the next question, next class, we will use certain kind of like how we can divide anything into too many proportions and too many ratios. And what is proportion? We also add something like variation also. So these are the upcoming classes of ratios. So see you guys in the other videos.